Right now, everything around you seems quiet. The ground feels solid beneath your feet. The air is still. You're likely sitting in a chair watching this screen, feeling completely stationary. But this is an illusion. The reality is, you're moving faster than you can imagine. First, the Earth is spinning at 1,000 miles per hour. Simultaneously, we're orbiting the Sun at 67,000 miles per hour. But even that is nothing compared to the true scale of our cosmic journey. Our entire solar system, the Sun, the planets, and all of us, is drifting through the Milky Way galaxy. And the galaxy itself is tearing through the universe at over 1.3 million miles per hour. We are not wandering aimlessly. We are being pulled. Decades ago, astronomers discovered something terrifying in the data. They realized that the Milky Way, Andromeda, and millions of other galaxies in our neighborhood are all rushing towards a single specific point in the deep universe. We are flowing like water in a river, sliding down a gravitational slope towards a mysterious destination. To generate a gravitational pull this massive, there must be something colossal waiting for us, something with the mass of tens of thousands of galaxies. But here is the true mystery. When we look towards our destination, we see nothing. By a cruel cosmic coincidence, this massive object lies directly behind the dense centre of our own galaxy. The dust and stars of the Milky Way act as a thick curtain, blinding our telescopes and hiding the monster in the dark. Scientists call this region the zone of avoidance, and inside that hidden zone lies the Great Attractor. What is it? Is it a supercluster of galaxies? Is it a rupture in space-time, or is it something we have not yet discovered? In this documentary, we're going to peel back the curtain. We will map the invisible currents of the cosmos, explore the terrifying voids that are pushing us away, and hunt for the gravitational ghost that is pulling us in. Where are we going? And what will happen when we finally get there? This is the story of the Great Attractor. To understand the terrifying speed at which we are moving, we must first look at the map of the territory. For centuries, astronomers looked up at the night sky and assumed the universe was chaotic. They believed galaxies were scattered randomly across the dark, like sand grains thrown across a desert floor. From our perspective here on Earth, it certainly looks that way. But we were wrong, cruelly wrong. As technology advanced, and as we mapped the positions of millions of galaxies, a startling pattern emerged from the darkness. The universe is not random. It has an architecture. It has a design. We call this structure the cosmic web. If you could zoom out far enough, the universe would look incredibly similar to the neurons in a human brain. Imagine a vast, three-dimensional spiderweb stretching across the entire cosmos. In this web, galaxies are not isolated islands. They're connected. They're strung together along massive invisible bridges called filaments. These filaments are made of gas and dark matter, acting as the highways of the universe. They can stretch for hundreds of millions of light years, connecting one corner of the cosmos to another. Where these massive bridges intersect, we find the cities of the universe, gigantic clusters containing thousands of galaxies. And between these filaments lie the voids, regions of absolute emptiness, cold, dark, and dead. Gravity is the sculptor of this landscape. It is the invisible hand that shapes history. Over billions of years, gravity has been slowly pulling matter out of the empty voids and flowing it onto the filaments. This creates a cosmic flow. Just as rainwater flows down the side of a mountain into a valley, galaxies flow through these magnetic highways towards regions of higher density. We are not sitting still. We are migrating. But this raises a fundamental question. In the emptiness of space, there is no wind to feel on your face. There are no landmarks to pass by. So how do we know we are moving at all? To find the answer, we have to look at the oldest light in existence. The cosmic microwave background. This is the fading heat left over from the Big Bang itself. It is a sea of ancient radiation that fills every inch of the sky. Think of it as the frozen reference frame of the universe. If we were standing completely still, this background heat would look exactly the same in every single direction. The temperature would be perfect and uniform, but when we measure it, we see a disturbance. When we look in the direction of the constellation Leo, the universe looks slightly warmer. The light waves are compressed, appearing bluer. When we look in the opposite direction, towards Aquarius, the universe looks cooler. The light waves are stretched out, appearing redder. This is the Doppler effect on a cosmic scale. It is the same effect that changes the sound of a passing ambulance. We are rushing towards a specific point in the sky so fast that we are literally crashing into the ancient photons of light. This proved without a shadow of a doubt that we are moving. But when astronomers calculated the speed, they were shocked. We're moving at nearly 400 miles per second. There was a problem, a big one. The math did not add up. They calculated the mass of the Milky Way. They calculated the mass of our neighbour, Andromeda. They even added up the gravity of every galaxy in our local cluster. It was not enough. There is not enough visible matter in our universe to generate the gravity needed to pull us at this speed. Something else is out there. Something colossal. Something with the mass of tens of thousands of galaxies is lurking at the end of the river, and to find it we have to look into the one place where our telescopes are blind. So, we know we are moving. We know something colossal is pulling us at incredible speeds. Naturally, astronomers wanted to look at the destination. They pointed their most powerful telescopes towards the source of this gravity. They expected to see a monster, a massive supercluster of galaxies shining in the dark. But they saw nothing. This is the greatest irony in the history of astronomy. By a cruel cosmic coincidence, the object that is pulling us lies directly behind the centre of our own galaxy. Imagine you are in a forest. You can see the trees far away in the distance, but you cannot see what is hidden directly behind the massive tree trunk standing right in front of your face. The Milky Way is that tree trunk. Our galaxy is a flat disk filled with thick clouds of dust, gas, and billions of brightest stars. From our perspective on Earth, this creates a dense wall of light and shadow across the night sky. It acts like a cosmic curtain. Any light coming from behind this curtain is blocked. It is absorbed by the dust long before it can reach our telescopes. Roughly 20% of the entire universe is hidden from our view because of this. Astronomers call this blind spot the zone of avoidance. It is a forbidden zone where optical telescopes are useless. For decades, we had no idea what was lurking in that darkness. We only knew that something massive was there, pulling us, dragging us. It was not until the invention of radio telescopes and infrared astronomy that we began to peer through the fog. Unlike visible light, radio waves can travel through the dust. And when we finally looked into the zone of avoidance with these new eyes, we found something terrifying. The region was not empty. It was densely packed. We discovered a gravitational anomaly so large that it bends the fabric of space-time itself. We named it the Great Attractor, but even then the mystery did not end. Because as we mapped the area we realized something even stranger. The Great Attractor is massive, yes, but it is not massive enough to explain our speed. It is just a stepping stone, a breadcrumb leading to something even bigger, something lying even deeper in the shadows. For decades, the Great Attractor was the ultimate mystery. We thought it was the end of the line, the final destination of our journey. But science never stands still. In 2014, a team of astronomers redefined everything we thought we knew about our place in the universe. They realized that the Great Attractor is not an isolated monster sitting in the dark. It is just the dense center of something much, much larger. To understand this, we have to change how we think about gravity. Think of the universe as a landscape of hills and valleys. Gravity creates the slopes. Just as rainwater falling on a continent will flow down into rivers, and those rivers will flow into a central ocean basin, galaxies behave in the exact same way. They flow down gravitational slopes, merging into larger and larger streams, heading towards the deepest valley. When scientists mapped the flows of thousands of galaxies around us, they found the boundaries of our cosmic continent. They discovered that the Milky Way is part of a titanic supercluster of galaxies. They named it Laniakea. In the Hawaiian language, it means immeasurable heaven. The name fits perfectly. Laniakea is staggering in its scale. It stretches for over 500 million light-years across the void. It contains more than 100,000 large galaxies and over a quadrillion stars. Its total mass is 100 million billion times that of our Sun. And every single star, every single planet, and every single galaxy within this massive structure is connected. We are all caught in the same gravitational current. We are all sliding down the same slope. And where is the bottom of this slope? Where is the drain that all these cosmic rivers are flowing into? It is the Great Attractor. The Great Attractor is simply the focal point of Laniakea. It is the downtown area of our cosmic city, the place where the gravity is strongest. So, where are we in this grand map? We are not in the centre. We are out in the suburbs. The Milky Way lives near the very edge of Laniakea. We're like a small boat far up a river, just beginning our long, slow journey towards the central ocean. This discovery was a triumph of science. We finally had a map of our true home. It seemed like the puzzle was solved. But the universe had one more terrifying twist waiting for us. Because when astronomers looked at Laniakea as a whole, they noticed something disturbing. Our entire supercluster, all 100,000 galaxies of it, is moving too. For a long time, we focused only on what was ahead of us. We were obsessed with the Great Attractor and the massive structures pulling us in. But in 2017, astronomers realized we were missing half the picture. Think about a car moving down a highway. It moves because the engine pulls it forward. But what if the road itself was tilted? What if, in addition to being pulled from the front, we were also being pushed from behind? This is exactly what is happening to our galaxy. Scientists discovered that the gravitational pull coming from the Great Attractor was not enough to explain our velocity. The math still felt wrong, so they turned around. They looked in the opposite direction of our travel. And there they found something terrifying. A void. But not just any void. This is a region of space so empty, so devoid of matter, that it defies imagination. They named it the Dipole Repeller. Now, you might ask, how can an empty void push anything? Gravity is supposed to be an attractive force, not a repulsive one, and you would be right. Technically, the void is not pushing us. It is doing something much more subtle. Imagine a game of tug-of-war. On one side, you have the massive superclusters pulling the rope. On the other side, you have nothing. The void has no gravity. It has no grip. So, the dense regions win the tug-of-war easily. Because the void is so empty, it exerts almost no gravitational pull on us. This creates a pressure difference. We are falling away from the void and falling towards the attractor. So, the Dipole Repeller acts like a vacuum cleaner behind us, while the attractor acts like a magnet in front of us. We are caught in the middle of this cosmic crossfire, running away from the emptiness and rushing towards the monsters in the dark. This discovery solved the final piece of the velocity puzzle. We're moving so fast because we're being worked on by two forces at once, a push and a pull. For years we believed the Great Attractor was the master of our destiny. It was the heaviest thing we knew, and it seemed to explain everything. But as our instruments became more precise, a doubt began to grow. Astronomers calculated the mass of the Great Attractor again and again, and every time the result was the same. It was heavy, yes, but it was not heavy enough to pull us across the universe at 1.3 million miles per hour. It was like blaming a magnet for moving a train. The physics did not work. So we had to look further. We had to look past the Great Attractor deeper into the zone of avoidance, and there, sitting in the darkness 650 million light-years away, we found the true monster. It is a structure so massive that it makes the Great Attractor look like a dwarf. We call it the Shapley Supercluster. This is the most massive concentration of matter in the local universe. It is a supercluster of superclusters. Imagine a city of galaxies packed so tightly together that their gravity dominates everything around them for 1 billion light-years. To give you a sense of scale, the Shapley Supercluster contains the mass of more than 10,000 Milky Way galaxies combined. Its gravitational pull is so strong that it is dragging our entire home, Laniakea, towards it. We thought we were flowing towards the Great Attractor, but in reality the Great Attractor itself is being pulled towards Shapley. It is just a local highway stop on the way to the final destination. Now, the full picture is finally clear. We are not just moving randomly. We are part of a massive flowing river of gravity. Behind us, the Dipole Repeller is pushing us away with its emptiness. In front of us, the Great Attractor is pulling us in, and far beyond that, the titanic Shapley Supercluster is dragging the whole system into the deep universe. It is a perfect storm of gravity. This combined force explains our incredible speed. We are surfing on a gravitational wave created by the biggest structures in the cosmos. But this leads to one final chilling question. If we are rushing towards this monster at millions of miles per hour, will we ever get there? Or is the universe planning a different fate for us? So, after all this detective work, we finally know the answer. We know that we are part of the Laniakea supercluster. We know that we are being pushed by the Dipole Repeller, and we know that we are rushing towards the titanic Shapley supercluster at millions of miles per hour. It feels like we're on a grand journey to a specific destination. We imagine that one day, billions of years from now, we will finally arrive at the center of this cosmic city. We imagine meeting thousands of other galaxies in a glorious reunion of gravity. But the universe has one final tragic twist in store for us. And while gravity is trying to pull everything together, there is another force working against it. A dark, mysterious energy that lives in the empty vacuum of space. We call it dark energy, and it is tearing the universe apart. Right now, gravity is winning the local battle. It is keeping our galaxy and our immediate neighbors together. But on the grand scale, dark energy is winning the war. Space itself is expanding, and it is expanding faster every day. This means that the ground is literally moving beneath our feet. The space between us and the Shapley Supercluster is stretching. Even though we are moving towards it at incredible speeds, the destination is moving away from us even faster. It is a cosmic race that we are destined to lose. We are like a sailor rowing a boat against a current that is too strong. No matter how fast we go, the horizon keeps receding. So the sad truth is that we will never reach the Great Attractor. We will never reach the Shapley Supercluster. Those massive structures will eventually fade away into the darkness, carried away by the expansion of the universe. In the far distant future, billions of years from now, our view of the cosmos will change. The other galaxies will disappear beyond the horizon. The sky will become dark and empty, and our galaxy will be left alone, floating in an infinite silent void. We are travellers on a bridge to nowhere, chasing a ghost we can never catch. But perhaps the meaning is not in the destination. Perhaps the meaning is simply in understanding the journey.